Hello, everybody. Welcome to the OpenUSD Insider's live stream. I'm your host today, sitting in for Edmar. My name is Shane Reitz, and joining me is my colleague, Kartik, and got a really exciting presentation for you today. So this is one of our partners, Vention. They are developing smart manufacturing solutions. So transforming industrial automation using NVIDIA Robotics technologies with plug-and-play solutions. So we're going to go over MachineMotion AI and a lot of the NVIDIA technologies that underlie that, which my colleague Kartik, solutions architect in robotics and physical AI at NVIDIA, is an expert in. So welcome, Kartik. Thanks for joining me today.
Yeah, thank you so much for having me on the live stream. Really excited for what we have done together with Vention and a lot of exciting work, like from the hardware, from the foundation models. So really excited for today.
Yeah, thanks for joining. And it's really great to have both sides, right? This the NVIDIA technologies and the collaboration with Vention. So let's bring on our guests from Vention. We have Francois Jaguer, who's the CTO at Vention. Welcome, Francois.
Thank you, Shane. That video got me really excited.
And Jimmy Lee, who's Director of Physical AI at Vention. Also, welcome, Jimmy.
Yes, hi, everyone. It's great to be here today.
Yeah, thanks so much for joining. So I guess we'll start. Kartik, you want to give just a short intro of what you do at NVIDIA? I gave just your title, but tell us a little more about what you do today.
Perfect. So basically, I'm a solution architect in robotics and AI based in Munich. So I've been helping my partners on a lot of robotics workflows, for instance, GRUD, like other foundation models. So a lot of exciting things, Omniverse, Isaac Sim, Isaac Lab. And I've been it's been a learning journey for me since ever I joined.
Now, there's always so much more to learn in this world. Francois, could you just tell us a brief bio, what you do at Vention and a little about your role?
Yeah, absolutely. So I started at Vention in 2017. So we were 4 back then in the company. So I started at the very early days of the business, and my focus at the very beginning was to focus on automation controls. So that's what I did first in the company. And after a while, I took on more responsibility in the organization, more on the software side, because I was, initially more electronics controls and firmware, but then started to lead other initiatives and took over the role of CTO about 2 years ago. So now I lead the entire technology organization, which is very varied, as you'll learn, throughout our conversation today. I'm sure, we go from mechanical component design, electronics, firmware, communication protocols, and full stack software, so web development and web tools. So this is my short bio. And before Vention, I worked for about 7 years at General Electric in real-time controls firmware in electronics.
Awesome. Thanks for sharing. And yeah, I know from my experience with Vention, the first time I heard of Vention was when we ordered a robot base for a cobot. And that's really just, it's been fun to learn more and more about everything Vention gets up to, because there's a lot more. We'll learn about that.
There's a lot.
Jimmy, can you tell us?
Sure. Yes. Hi, everyone. I'm Jimmy. I'm currently the Director of Physical AI at Vention. Previously, I did my PhD at McGill University, where I worked on robotics. My PhD thesis was on SLAM, but I also did some work on underwater robotics. After I graduated, I spent some time at the Samsung AI Center in Montreal, where I did work on reinforcement learning. And I joined Vention fairly recently, October of last year. And after I joined, I focused primarily on bin picking, and I worked on the bin picking demo that we showcased at GTC of this year, and we'll show some videos of that later during the live stream as well.
Yeah, that was a really impressive demo. Anybody that was at GTC San Jose this year might have seen that or seen videos of it online. Really impressive demo, and we'll learn more about that today. I think anybody who's interested in industrial automation will be impressed with this kind of thing. I mean, it's a hard problem to solve, and they've done given like a plug and play way to do it, which is really interesting. So before we dive in, Kartik, could you just give a little more about in this relationship, this project of NVIDIA Vention, and then we'll dive into presentation. I think we have a cool video to start off with after that.
Yeah, why not? I mean, Vention and NVIDIA has been like a great partner in this manipulator side of industry. And we have been using the GPU-accelerated NVIDIA libraries, for instance, Foundation Post, Foundation Stereos, QMotion, which is really reshaping the manipulator smart robotics industry there. So, with this, with Vention's MachineMotion AI hardware and our Jetson platform, we are able to, get the solution out to the market in a faster way, which is robust. And also, since AI is at the edge, you don't have the dependency solely on the cloud there. And then also, with their unique solution, you can remotely manage your stuff. And also, this gives a lot of flexibility at the customer's side there. So I think we have done a pretty good partnership, and we've been. I mean, I've seen Vention at GTC, at Automatica. I mean, their demos, their workflows. And sometimes I see, it's just like a baby where you see that, you've been nourishing it for a long time. And then when you see at any trade show or anywhere, it's just so exciting to just see the product live in front of your face. And again, in this live stream as well, I'm really looking forward, the things that we have done together, and we have come a long way. And there's still a long great things to achieve there.
Yeah, there's always more, but the satisfaction of seeing those kind of demos out in the wild is real, and probably why a lot of us get into robotics, seeing those things
exactly
in the real world. So, and just one quick thing, stay tuned towards the end. We're going to show more about those packages, these tools that Kartik mentioned. We've got some courses and other materials to help you learn about Isaac Ross and QMotion and all these really interesting packages. But I'd like to pass it over to Francois to start sharing more about MachineMotion AI in this platform.
Sure. And maybe I can add a little bit, Shane, on the history with NVIDIA, because it's I think it's a little bit special because Vention is half software and half hardware, and we started a relationship very early on with the speccing of the Jetson inside our latest generation of MachineMotion AI. So as soon as we added the GPUs inside our product, then we started looking to more software, more capabilities, and it was really special how naturally things went. We didn't go directly to Kartik and his team saying, oh, we want to add AI. We went from the hardware, then we looked at the integration of the product, and then progressively we added more and more. And we saw all these pieces, how much they made sense and how, they were cohesive. So when we started with the first block, everything kind of like came together nicely. So I just wanted to add that, even if it took, over 18 months to build this relationship, I think it was quite organic and seamless, and it was a pleasure to work with the team. So the baby is coming to life.
It has been super exciting, with working with Vention there. The team is really smart, like our workflows, they're able to implement it really fast and then deploy it at the edge. It just gives us how do you say a good feedback on the things that the whole, because if you see from NVIDIA side, it goes from the research to engineering and then to the solution that brings to the market. So it's a whole complete chain, and then partners like Vention really bring it to the market. So without any further ado, let's hear from Francois himself.
So sounds good. Shane, do you want to get us started maybe with the Vention video, just so we can put things in perspective, and after we'll jump in MachineMotion AI.
Yeah, that sounds great. Let's check out this demo.
When it comes to manufacturing, nobody automates faster than Vention. Design automated equipment right in your web browser. Go from concept to production in days, not months. Our drag and drop machine builder software allows you to design, program, simulate, and operate your system all in one seamless environment. Build with the industry's largest ecosystem of modular, plug-and-play parts, engineered for guaranteed compatibility. Or get started with a turnkey system, shipped pre-assembled and ready for operation in a matter of days. Trusted by more than 4,000 customers, big and small worldwide, to boost productivity, cut costs, and drive scalable growth. Automate faster, scale smarter. Future-proof your business with Vention.
All right, cool. Thank you, Shane. So the reason why I wanted to play this video is because I always tell everybody at Vention, when they start to talk about Vention, to just show a video, because it's, you know, it's a very complex business model, and, you know, because it's the integration of very many things. So I just wanted to kind of put a mental picture in everybody's mind before we get going with the rest of the chat. So I can talk a little bit more about Vention. What we've done really is, and our goal is to simplify industrial automation. We want to make it lower cost. We want to make it faster and easier for people from around the globe to to automate their production, their facilities. And what we did, our strategy was, let's integrate all these blocks that are all these workflows that are necessary into one digital platform. So when you do automation, you always need, you know, hardware components. So we build a library of plug and play components. You always need to put things together and to do 3D modeling. So we build Machine Builder to put all our components together. You always need to program a machine if it's automated, obviously. So we created some programming environments that leverage the tools and the assemblies. And then we built a simulation engine and then an e-commerce platform. So when you put all of this together, the result is you can build automated systems much faster at a lower cost and much more simplistically. So you don't necessarily need to be an expert, or if you're an expert, you can do it much faster. But, you know, with this goal of making things simple, when we put all these blocks together, we saw an opportunity to leverage AI to make things even simpler. So, you know, dexterity came in the picture, perception came in the picture, and also more advanced motion planning. And then when this came, we decided to, you know, partner with NVIDIA to bring the Jetson platform inside our controller. So this is where we're going to talk about MachineMotion, because, you know, I talked briefly about Vention, you know, the platform, but at the heart of any automated system, we have MachineMotion. We have 3 generations so far. We were very creative early on. We had MachineMotion 1 and MachineMotion 2. And then, you know, we decided to change the scheme. So now we call it MachineMotion AI, because we brought this new platform that has GPU acceleration. So what is MachineMotion? For those that are not aware, it's the core of any automated machine invention. It's the controller. It's where you run your software. It's where all the controls run. It's where all the components come together. So if you go to the next slide, Shane, we'll see just a little, you know, example of how the controller becomes the central part of a Vention system. We can connect robots, safety devices, IOs, motors. And the beautiful thing is you don't need to do complex engineering to make these things compatible. It's a little bit like Lego Mindstorms, for those who know about it. Or, you know, your Apple components at home that kind of seamlessly connect together. Everything is pre-configured, pre-discovered. You have software APIs for all these components, so it's very straightforward. So that was our vision since the beginning, and we've made it more and more tangible and real as the business grew. So with this 3rd generation, the special part is distributed motion control, but also the addition of GPUs. So we, like I said before, we partnered with NVIDIA early on the design of this new generation of the controller, and we brought in a Jetson NX 16 gig inside. So if we go to the next slide, Shane, you know, this little marvel of technology, about the size of a credit card, is now inside the controller. And there's a lot of people that, you know, challenged me and challenged Etienne, our CEO, and why we were doing this. You know, some people say, oh, AI, it's just, you know, it's just a trend. It's just to sound flashy. But, you know, what we wanted to do was simple. It was to start to utilize AI to make the act of creating machines even simpler. And there's 3 things that we really wanted to push forward with this technology. And if we go to the next slide, the 2 first ones are about dexterity and perception, right? We want machines to perceive their environment much more easily. So utilizing vision instead of utilizing, we made some crazy machines at Vention with like dozens of sensors to sense a part or which SKU was coming on a conveyor. But now with AI-driven perception, we can massively simplify things, right? We can simplify gripper, we can simplify mechanical staging devices and sensing. So AI-driven perception is one big thing that we wanted to push forward with GPU technology, GPU compute, and NVIDIA. And the other thing is dexterity, right? How do you go about picking apart? How do you position yourself to do so? So this is also another big field where we're pushing. And if we go to the next slide, the other place where we really wanted to push is 3D aware or context aware motion planning. We don't want our customers to always have to create different routines depending on the SKU they manage or depending on the context of the machine that day, or in a factory if there's a post. We don't necessarily want to always do something differently. So by leveraging QMotion, a technology that was developed by NVIDIA, we can tell the robot, here's your 3D scene, go from this point to this point, and manage all the complexity that's in between these 2 points. We were always of the philosophy that motion streaming is the right approach for the future, meaning that the controller of a system streams data point to a robot. And this ended up being very aligned with the technology that NVIDIA was building. So, our technological strategies were really close cousins. So this was really seamless when the time came to leverage the technology. So I just wanted to give an overview of Vention, low-cost machines, have them fast, make it easy, then put GPUs inside the center brain of the cell, and basically create perception simplicity, dexterity simplicity, and motion simplicity, right? This is what where we're headed. And Jimmy, the fantastic scientist that joined us last year, will tell you more about exactly what type of technology we're taking from NVIDIA and putting inside our products to make this come to life.
Excellent. Yeah, and I just highlight for folks following along, if you hear us talking about this 3-computer solution of physical AI, this is that third computer, right? This is the GPU at the edge.
Absolutely.
So, you might use the DGX, we say, is training your model at a massive scale. You need like a supercomputer, and you're doing generating the models that are running these things. And then we have OVX running simulation, and then this is AGX. This is that edge, GPUs at the edge. So this is a really interesting combination of worlds with industrial automation and how do you get those resources at the edge. So
exactly.
Do we want to, Kartik, are you going to show some of these technologies with Isaac Manipulator? Should we cover that next?
Yeah, why? Yes, why not? Let's, now that you've talked about the 3, like the 3 computers, so here it is where you can see, we have this, the big cloud where we can train the foundation models. Some of them I already said before, like foundation stereo, foundation pose. And also there's this GROOT model, which is a world foundation model for the humanoids. And so this is kind of like a cloud structure, like maybe it can be on-prem, where you can train big models. It could be VLMs or LLMs, or like any specific models. And then once you have trained this model, that is you can also augment using some simulation data, for instance. That's where the second computer comes into the picture, which is right here. So this is for this we have the platform called Omniverse. And Omniverse, and there are reference applications built over it, for instance, Isaac Sim. And then that is for, robot simulation. We can also use Isaac Lab, and that is for reinforcement learning, where we let the robots learn, let they do their tasks, And then once we have this policy strains, we can actually deploy it on the edge. That's what, Francois just showed us, where we have this Jetson or those platforms where we can actually deploy those policies there. So if you see, we have these foundation models, we have the simulation platform, and then augmenting it through the synthetic data, we can really augment, these things to the next level. And that's one of the solutions that NVIDIA actually brings to the table on this front there. So I mean, it's all a tandem of, it's a loop. So for instance, you trained a policy, then you want to evaluate, let's say in a simulation, how well it works before you actually deploy it. So, and once it meets your KPIs, then it's well and good. If not, you would again do this loop. So for this, we have this whole technologies. So one of the So one of the applications which is also built is NVIDIA Isaac ROS. So basically, these are the CUDA-accelerated libraries and AI models that are freely available on GitHub. So for instance, we have visual SLAM, 3D reconstruction, pose estimation, or object detection, so on and so forth. So these are all packages which are available on GitHub and via Isaac ROS. So Isaac ROS is nothing but it's built over the standard open source ROS framework with the CUDA-accelerated libraries there. And so these are all built on TensorRT, VPI, CUDA, Argus, and these drivers, so on and so forth. So, so to actually bring these models in a package, we have these reference architectures. For instance, Isaac Manipulator and Isaac Preceptor, and Vention here is one of the examples of Isaac Manipulator, wherein we are using these foundation models on actual deployment there. So let's see what Isaac Manipulator it is. So basically, it's a reference workflow for the autonomous manipulation, wherein we have the 6D pose estimation and tracking. This is being delivered by the foundation pose that I've been mentioning, since the start of my video. And there we also have a motion planning package, which is the QMotion. Then for grass identification, manipulation, and dexterities. So all these packages are they come up with Isaac ROS, or they're also available on our GitHub pages. And then these packages can actually be deployed on our Jetson platform there. And here you can see how these model actually look like in the real world, wherein we have this the manipulator doing a pick and place, for instance, and then it can do a 3D reconstruction of the scene there. So this is how the whole pick and place orchestration pipeline looks like. So for instance, so we have the cameras. Maybe it could be in a real world. That's what we saw with Vention doing it, or maybe these cameras can be actually be in a simulator. For instance, Isaac Sim. So the moment the images from the cameras come, they can go to the object detector. For that, we have a synthetic DTR. So this basically detects the object. When I say object detection, it means what kind of object it is. The type, for instance, if it's a metallic piece, like a blob, so on and so forth. And then it goes to the pose estimator as well. And when I say pose estimator, it is actually it predicts the 6D poses of the object in the real world. And 6D poses means like where exactly the object is with respect to the robot there. So like the X, Y, Z, and then the rotation in the X, Y, Z plane as well. And also it goes to the 3D reconstruction, which is called NV blocks, and this basically reconstructs the whole scene. So what the surrounding of the robot looks like. So once these motion go there, we get the what object is. Once after this, we get the pose of the object. Once we have the pose, we let's say we command the robot to go towards to get the action done. So that's how the whole pick and place pipeline, or kind of the architecture looks like. And so yeah, and these all things can be deployed on our Jetson platform, or also it can be on a discrete GPUs there. And this is how the Isaac Manipulator looks like with Isaac Sim. So on the right side, you can see we have an actual scene of a manipulator picking up let's say a can, and then the idea is to place it in the box which is right in front of it. So if you see very carefully, we have a camera which is actually looking it from the third view person perspective, and then it does the depth estimation, how far the object is. It does the 6D pose estimation, where exactly the object is with respect to the robot base, and accordingly, and also it detects if there's an obstacle or not. For instance, this box. So all this information, like what I presented you before with QMotion, with foundation pose, foundation stereo, and with these libraries, we can actually get the feel of the environment, and then the robot goes there, it grasps, and then it avoiding the boundaries of the box, it places inside the box there. So that's how this Isaac Sim works in tandem with RViz, or with any standard ROS framework that comes along. And so since these things have been exploding a lot, there are a lot of new things coming up very fast, very soon. So we have a lot of courses, and also reference architectures, documentation, codes, so that we give the power to the hands of the developers to make great things from our reference architecture or the work that already been done, instead of each developer building their own wheel. So, and why not? We have these tutorials, the concepts, and a lot of things. And also there are developer forums wherein the developers are free to open up for discussions. If they have any feedback to us, feel free to give a feedback on our libraries, on our tutorials, or on our packages. And there we can inculcate that. And that's how we let's say it's a learning machine, and then we grow together. So talking about the courses, why not, Shane, you talk about some physical AI and robotics fundamentals that we have and we offer to the community there.
Yeah, sure. Well, first of all, I just want to say thanks so much for going over that. There's a lot to digest in that, but I think each step of that pipeline is like an interesting tool that's worth its own exploration. I mean, just foundation pose, being able to estimate the pose of an object in space, its position and orientation. I mean, there's so much you can do with that, and that's one part of it, right? So I think it's really worth taking a deep dive and looking into these. And as let's see, the links. Yes, we'll get the links put up for the courses as well. But these tools are available for everyone. Correct me if I'm wrong, Kartik, but all Isaac ROS and all these packages are available right now for people to use. And Vention is an example of a company taking those and making it into a full solution, like a plug-and-play solution. So I'll talk more about the courses at the end. I want to get to Jimmy because he's been waiting patiently and has some really cool videos. So Jimmy, would you tell us more about how you've applied all these technologies we just talked about into the solution with MachineMotion?
Yeah, that sounds great. I'd like to start by showing a video demo of something similar to what we presented at GTC of this year. This was also shown at Automate and Automatica. So here you see a robot that is picking this gray part. It's a plumbing part from one of our potential clients. And as you can see, the parts are randomly placed inside a bin. And the robot is able to pick up these parts and place them in a structured way. So at the core of this demo is NVIDIA's foundation pose model, which enables us to use vision to estimate the pose of these objects in 3D space. And there's a camera that's mounted on the wrist of the robot, which is used to see the objects in the bin. By the way, when I say the word pose, what I mean is the rotation and the translation of the objects. And for this demo, all the processing is happening on board Vention's MachineMotion AI controller with the NVIDIA Orin NX. Okay, so that was just a demo. So next, I have another video of the actual cell. So this is a test cell that is built with the same dimensions as the real cell at our customer site. And what you see here is a bigger robot. It still has a camera that's mounted on the wrist, but there are some key differences here. So first, you see that we have a very deep bin, and this poses a lot of challenges. Because there's a very deep bin and the robot's hand, its gripper is quite big, we need to be able to avoid collisions with the bin. That's very important. And one other thing that you'll notice is that now, compared to the demo, every single time we pick up the part, we're holding the part slightly differently. And because of that, the way we place it is also different every single time. And this is important because when we're picking from a deep bin like this, there are a lot of constraints that we have to work with, right? We have to not hit the bin. And then also depending on how the part is oriented in the bin, right? Not all the grasps are available. And on top of that, we have to pick it in a way such that we can actually place it in the way that we want. So the strategy here is for every object, we have a large pool of candidate grasps that the robot can use. And then depending on the situation, the robot will make a smart decision about which of those picks to use. Right, so next, do you have the longer version of the video, Shane? That we can play?
Let me see here. Got a long version of the demo I'll show.
Awesome, thank you.
Okay, let's pick up at the end of, yeah, this is where it was ending.
Okay, great. Yeah, so this is a very long 24-minute run of the robot just picking this part. Just now, I think we saw the first 3 minutes, but this is the full length of the video. We won't watch all of it, but yeah, we'll just watch it while I talk about this cell. Okay, so another thing you'll notice is that we have this regrip station. So the reason we need a regrip station is, so by the way, the regrip station is that black thing there, and now the robot is about to put it on the regrip station. Yeah, so there, yeah, now it's on the regrip station. So the reason we need this is that there's very limited space inside the enclosure for the final receptacle that we have to place it into. And so the only way for the robot's arm to fit into this enclosure is to pick it from the top. And that's why we went with a regrip station. And this regrip station is actually performing another role, which is that when the part is placed on it, there's a mechanism that rotates the part and turns the part such that it has a consistent clocking. And this is important because to finally insert it into the receptacle, the part needs to have a correct clocking. So in this video, oh yeah, so this is the shaking of the bin. So whenever the robot fails to pick apart, we actually shake the bin just to mix it up and expose a different set of potential grasps that the robot can then consider. So in this demo, after we put on the regrip, here we see an internal grasp. So here you see both fingers of the robot are actually inside the barrel of the part. So that is one of the strategies that the robot can choose to use if the part is standing up vertically. Yeah, so here we grab it from the regrip, and then we insert it into the receptacle. Now here we actually take it back out and we drop it into a bin below. And that's just for testing purposes. For the real deployment at the customer site, once the part is placed inside the receptacle, the whole receptacle will actually move away for the next processing step. And a new receptacle that's empty will come into that position, and the robot can then put the next part in.
Wow. I mean, I know we said we weren't going to watch the whole video, but I think I could watch the whole video. This is really, really fascinating. I haven't tried this kind of thing. I mean, this is a difficult problem. That bin is not, as Jimmy mentioned, it's deep. You have all these objects just tossed in there in different orientations, and it's dynamically figuring out how to pick these up. I mean, I just need to emphasize how wild that is. And I could just watch this all day, but please go on, Jimmy.
Yeah.
And
so,
also, yeah, so I was just, wanted to mention that random bin picking is one of the the toughest problems to solve in the manipulator ecosystem. Because if you see, like most of the industries, they have like very organized or rather semi-organized way of placed objects, like where they want to pick it. But then the real problem and the real challenge really comes when you have random parts, and this is very a common scenario in industry. So solving a very hard problem definitely takes time, but then, if you have the right partnership, you can really take these things to the next level. That's and it's always, whenever I see this demo, it's really impressive. So yeah, over to you, Jimmy. Just wanted to add this
Well,
thing.
actually, if I can butt in with a small question, do you know what would be needed to take this from this particular part to a different part? Like, let's say you get a longer version of those connectors. What would be needed to change this behavior?
Mm-hmm. So it really depends on the part. So I'll give, okay, so first let me start by saying why bin picking is very, very hard, right? So one of the main challenges that we've observed is with the grasping. So when you stick your fingers into this big pile of parts, everything is moving around, right? And one failure case currently that we're dealing with is that sometimes when we stick the fingers in to grab one part, the fingers will collide with other nearby parts. Sometimes that's okay, depending on the geometry of the part and then where the gripper lands. But sometimes it's not okay, right? And it could lead to an unsafe collision, right? So right now we're testing with these plastic fingers. Sometimes they'll break, right? Like, let's say we try to grab one part, but there's a nearby part, and then the finger goes into the barrel of the part that's nearby, and that could lead to an unsafe collision, right? So that is still a problem that we're actively working on. So now to come back to your question, Shane, right? So if the parts in the bin have certain physical properties that that doesn't cause too much problems, right? Then it could be quite easy. And the cool thing with these foundation models like Foundation Pose, right, is that we don't have to train it on a new part. All we have to do is provide it with a new CAD model of that part, and right away it's able to detect that part. And the only other thing we'd have to do is to program some of the grasps. And we are exploring ways to automatically generate those grasps based on a CAD model. And I know that NVIDIA is also doing work on that, right? And so in the past, there has been cases where it only took us like a day to onboard a completely new part. And that's, once again, due to these foundation models not needing to train. Now, where it can get hard is that because we haven't fully solved this dexterous grasping problem, right? Let's say you give us some other kinds of part that has certain physical properties such that it's very hard to squeeze your fingers in between parts, right? Maybe the parts are very heavy or such that when you put your fingers in, they don't naturally spread out, right? Then we could run into problems. And I would say that's still kind of like an open research problem, right? That we don't yet have a great solution for.
Sure. Yeah, and I just want to point out, Theodore asked us a similar question at about the same time. So maybe Kartik, you could, if you're open to it, I'm just putting you on the spot here, but cover this question in terms of the NVIDIA technologies.
Yeah, I mean, why not? Like as Jimmy mentioned that, so having foundation models into the pipelines, for instance, Foundation Pose or Foundation Stereo, it really brings down the installation time, or rather, training for or rather teaching for a new part. Because if you see from a conventional, let's say, manipulator side of industry, even if it's using, let's say, conventional models, not a foundation model, so it would take them days of development to get let's say a deep learning model trained on a specific part. So it requires a lot of development time, a lot of compute resources, and also a lot of hit and trial errors, and getting the right resources. So if you count all of these in place, it's actually a very long development cycle that happens. So on the other hand, what with these foundation models is the fact that we have done the part. We have got these these foundation models in place for you, and then like the only ask here is, for instance, you just so Foundation Pose also works with the CAD model, and it also works with the CAD free models, depending on some conditions there. So if you have a CAD model, which is pretty much very standard in any industry, especially in the manipulator industry, if you have the CAD model there, you just plug into that and then actually just do it one shot. So this really brings down the downtime time. And then Foundation Stereo has seen a lot of success across industry, across researchers, where it is doing a one-shot solution to unseen parts. So this has really, bring down the cost of development and the resources needing to train these models again and again. And now the whole, let's say, the efforts lies in actually bringing up plumbing these all solutions together. Going from a motion planning, and also for motion planning, we have these CUDA-accelerated libraries, which really helps you, having an dynamically planned motion planner, which also helps in these downtown times. So I would highly, so in this way the time has really reduced. So yeah, I mean, I would answer in this way.
Awesome, thanks.
Yeah, and I can, on our side, Karthik, just to echo what makes this technology absolutely a game changer for us is to deploy bin picking and vision solution at our customers. The training time and the uncertainty of adding a new part is large if we're not using that type of technology. And with the foundation model, we found that using a simple CAD, retraining foundation pose or specializing foundation pose has been extremely effective. And we've mentioned in the blog post that we've done a couple of weeks together that this model has exceptional resilience to lighting condition changes, and it's true. It's been absolutely amazing. So just the ability to add a new part in the pipeline is much better than a traditional model. So that's one big game changer. And the other portion is we see a path to automating the grasp planning. We're not there yet, like Jeannie said, but we really truly believe that with the tools we have, with the second computer, the simulation computer, we can get to a point where for each new part you add, you don't have to reteach the grasp points that are valid. You can have an automated simulatable step to do this. So you go from a world where you need to choose every grasp, you need to train every part, you need to refine with field data, to a world where grasps are automatic and adding an object is as simple as uploading a CAD into a pipeline. This is really a game changer. And again, aligned with faster to market, lower cost, more straightforward.
Yeah, and just comparing this with how you do this, I'll say, tradition, if that's a word, for traditional robotics, this would be difficult. It'd be a huge reprogramming effort to make something like this work with a new part.
And I think a gentleman mentioned, was talking in the comments about, bowl feeders. Bowl feeders are great. They've been used for, decades. They're effective, but they're highly inflexible. So if you are machining bolts, millions of them a day, it makes sense for the volume, but the type of situations we get across in our customer base is always a new part. The SKU mix is very varied. So having a bowl feeder is difficult for a very large SKU count. So then you need something much more flexible, which that type of solution we're showcasing here is.
Excellent. Yeah, thanks for answering that question. That was a good question. And then I'll just go through one more question, then I'll let Jimmy keep going here. Rob had a question about the gripper and how it's just, I think it's, how is it deciding how to grab, how far to grab? Is it pressure? Is it torque? How's this one working?
Yeah, so we have some, so currently we have some grasps that we manually coded. So given the CAD model, we generate just based on a manual analysis of the part, we write a Python program that generates those grasps. Now, eventually, I think, so there are a lot of grasp samplers out there that we can use to automatically generate these grasps. And I think that's what we're going to move to eventually.
Excellent.
Yeah.
All right, well, we got a few more questions I've got bookmarked, but Jimmy, I want to hand it back to you to keep going here.
Sure. Yeah, so maybe we can move on to the next asset, which is a pipeline overview. Right, so just to give a high-level overview of our pipeline. So there are 4 key pieces of technologies that we use from NVIDIA. There's Foundation Stereo, Foundation Pose, NV Blocks, and QMotion. The pipeline starts by capturing a pair of stereo images from a stereo camera that gets processed by foundation stereo, which takes a pair of images and outputs depth. Now, I think foundation stereo is one of the most exciting technologies to come out this year because it allows us to use a very inexpensive stereo camera, just a commodity stereo camera, and get very high quality depth. Almost just by eye, it looks to me almost like LiDAR quality. So the camera that you saw us using in the previous demo videos, it's only costs around $500 or so. And yet we're able to get very high quality depth. And I will show a demo of that later. So once we compute depth using foundation stereo, then at the top branch of this pipeline, we give the RGB and the depth data to foundation pose, which uses that to estimate the pose of objects in 3D space. And from there, we can plan a set of grasps. Now, on the bottom branch of this figure, we also give the depth that's produced by foundation stereo to NVBlocks, which is then able to build a model of the environment. It's essentially a collision model. And then finally, we have QMotion at the end of the pipeline. So this is a motion planning library from NVIDIA that leverages the GPU. So this is able to take advantage of the collision model created by NVBlocks to plan a collision-free path through the environment for the pick and the place. And the cool thing about QMotion is that we're able to plan many things in parallel on the GPU. And that's important because if you remember earlier, I mentioned that we have to consider many candidate grasps to find one that doesn't collide with the bin, that fits with the object geometry in the bin, and also in a way that we can place it later, right? So we have to consider many different grasps, and being able to do that in parallel on the GPU is very advantageous.
Excellent.
Okay.
Yeah, really interesting to see how all these parts can come together. And I think we've got another video that shows more the inner workings and kind of visualizes what's happening. Should I pull that up next, Jimmy?
Yes, please. Okay. So in this video, you are looking at a demo of both foundation pose and foundation stereo. So just take a moment to take in the quality of this depth that is captured. That is computed using foundation stereo, right? And this was not possible previously using traditional stereo matching technologies, right? So foundation stereo really unlocks the ability for us to have high quality depth with a very inexpensive stereo camera. And also, Shane, if you could play that video one more time. At the top left in red, what you see is the output of foundation pose. So there we estimated the pose of that object, and then we plotted the mesh of the object in red. And as you can see, it lines up quite well with the depth.
Yeah, this is really impressive. This came from, you said it was, how much was this camera?
It's about $500.
Yeah, and that's really, really high quality data. That's impressive.
Mm-hmm. Okay, so we can go on to the next video. Okay, so this is a big point cloud that we've stitched together. So this is, in a way, it's also a demo of foundation stereo. Okay, so we have a bunch of very high quality depth images, and then we stitch them together. And so here you can see it's like basically our test cell, right? It's a scan of the environment, and this point cloud is then given to NVBlocks to build a model of the environment, which we can then give to QMotion to plan through this environment.
Excellent. And then I think we have one more.
Yes.
Final demo here.
Yeah. So here we see the robot picking a different plumbing part. It's from the same client. It's also a plumbing part. So for example, this part we were able to onboard very quickly, right? So within a day. So I think, yeah, like within like a few hours, we were able to start to pick this part. And this part is actually a bit easier to pick than the gray part. It's bigger. There's like more space between the parts. And yeah, so this was quite easy for us to get up and running.
Wow. And I had a quick question from Tom here, just while we're looking at this. It's just the camera on the wrist, right? Is there any observer camera in the system?
No, just the camera on the wrist.
Just the camera on the wrist. Okay.
Yeah.
Wow.
Yeah, this video is playing at 2x speed. It is an older video that we took a while ago, but the one that you saw earlier was 1x speed, was the actual speed.
Very cool. Wow. Yeah, I'm mesmerized by robots. I don't know if that ever gets old, but watching processes like that and watching it figure out a different grasps and its ability to adapt. And like before, watching some of the orientations the robot could get into to get a grasp, it's really dynamic.
Mm-hmm. Yeah.
Okay, so I think, let me look at our questions here. I think we got a couple that I'll bring up, and then we'll talk about what's next for Vention. And then we'll also show some more resources for you viewers to learn about these technologies yourself. And we've got courses, we've got docs, other great things to share. So let's see, one question from a LinkedIn user. What happens if there's a defect or anomaly on such a part? Is it recognized as a defect or an unknown part?
Yeah, so anomaly detection is not something that we've been working on. So our current system, the way it is, it would not recognize those defects. Like foundation pose, as long as your part kind of matches the CAD model you gave to foundation pose, then foundation pose will work, right? And foundation pose is actually quite robust. So even if the color is a bit off, or even if the shape doesn't match exactly, right, foundation pose will still work. Like we've actually used foundation pose to detect some slightly deformable objects, like these plastic pouches. That's where the shape is a little bit different every time. So even if there are some small discrepancies with the CAD model, foundation pose will still work. But that doesn't help us with detecting anomalies. Right? Yeah, so that's just not something that we're currently focused on.
Sure.
There are some really delicate things to be careful of when we automate, because some operators will do exactly what we just showed and do the anomaly detection naturally just as they go and sort through parts. So a lot of people forget that step, automate, and after realize, okay, now nothing else is actually looking at anomalies. So it's a super good question, and we come across that all the time. We could add it to the pipeline eventually, but as a service.
Sure. And then we've got one of our ambassadors, Muammar, goes by Lychee. He's doing a competition right now, I think, for Isaac Lab. I wish I had more details in front of me, but saying manipulators would be a cool topic for it. I mean, who's to say no to that, really? Cool community challenge he's hosting. And let's see, we'll take one more question here. Somebody asked, how did your team, I'm translating a bit here, I guess, how did your team scale up on learning all these tools? Were there tutorials you used or particular resources? I mean, you had this relationship with NVIDIA, obviously, but how did you guys get up to speed on these tools?
Yeah, I can provide some color on this one. Like we mentioned, me and Kartik at the beginning of the live stream, our collaboration is very, very deep and very fluid. So we've had the chance to work with the NVIDIA team very, very closely and have access to, we have a Slack channel with some NVIDIA people. So we've had the chance to work with them very closely and get our questions answered very fast. But of course, we've leveraged all the documentation and the knowledge base that they put together to create this product.
Exactly, and when we talk about the partnership there, it's really important for us to partner with to our clients there, because the products that we make is for the developers and to make our partners successful. So what happens is the fact that for instance we have these models that you saw, right? Foundation pose, foundation stereo. The level of product is, if you see, it's a whole life cycle of a product. It starts from the research, goes to engineering, and then it gets deployed. And then depending on that feedback, then it again goes to the research. It improves. So that's how, like I said, we are a learning machine. NVIDIA is a learning machine. So the products are also goes through this iterative cycle. So we deliver them, they give us a feedback, we improve our products, and then we do the next big things, or we solve the next big problems. And the problems that actually the Vention is solving, they're pretty hard. If you see, like the random bin picking is one of the complex problems in the industry right now, and the results that you're seeing, they are amazing. Totally. When I started with them, I mean, the team has been super good. For instance, whatever we deliver, it gets deployed very fast, and then we get a feedback very soon if it's working, it's not working. And that's how you learn together. And I've been really enjoying this, and I think it's been really good journey so far.
Yeah.
And I'll just add on to that a bit. So I think it's super great that NVIDIA is open sourcing the research code of a lot of these technologies. So for example, Foundation Pose, the code is fully open source. And that was my main way to learn, just reading the Foundation Pose code. So that's really that's great. And also the partnership with NVIDIA has been tremendous. So I was at CVPR earlier this year, and I actually had a few conversations with the author of Foundation Pose, and I was able to brainstorm with him, different ways to use Foundation Pose. So that has also been very helpful.
Excellent. And yeah, there's a lot of resources out there to learn, a lot of ways to approach these problems. So we'll share some resources shortly. Briefly, I want to call out some comments here. Austin asked, "Where's Edmar?" Yeah, Edmar. Nobody can fill those shoes quite, but I'm filling in. And Edmar's never far away. We see Edmar up in the comments a little earlier here. So I thought you were on vacation, Edmar, but I hope you're having a good one anyway. Edmar is our usual host if you're new to the stream. So I think we're getting close to the end here. So I think we just wrap up, and what's next for Vention and robotics at Vention, and how do people, engage with you guys or get started?
Yeah. So well, as you've seen today, lots of work on AI and on making perception, dexterity, and motion planning, bring that up to the next level. And engaging with us is very straightforward. We have, for prospective customers and people who would like to work with us, we have a team of application engineers who can help support you. So go to our website, vention.io, and contact us. We'll be happy to know what you're working on, what your projects are, and collaborate on making a system and showing you how our platform works. And I would say that's pretty much it.
Excellent. And then we've got a few resources and how folks can get started today. So I've shared a few links in the comments, but we have the Isaac Manipulator docs. We also have a course at GTC San Jose. Swapnish Nishwani did an excellent course on Isaac Ross and covered some of these packages. I think he used Foundation Pose, QMotion, and a few other of the tools that and that course is available here. We'll put that in the chat. And then Kartik, do you want to talk a little bit about some of the docs and other resources we have?
Yeah, why not? So if you can open the Isaac Manipulator doc from the developer.
Yeah, let me see here. Okay, and you want to see the docs page for Isaac Manipulator?
Yes, that would be awesome.
You just get that here.
So while the docs are opening, like I just want to give a quick heads up to the viewers here. So most of the workflows or the products or the services, we have extensive documentation of whatever of the things that we have mentioned, going from Isaac Manipulator, Foundation Pose, Foundation Stereo, QMotion. These libraries everything is well documented. We have the code, we have resources, we have the developer forum, and you have these quick start guides. So feel free to experiment out these libraries. They are open source. You can use Isaac ROS, for instance, and Isaac ROS is also it brings out a lot of packages, as you mentioned. So it really it goes from the beginners level to the developers who really want to explore and take things to the to the next level. And as you can see on this page, we have this the QMotion, the NV blocks, stereo depth, everything is well documented. Going from how the pipeline looks like from the overview, and then going into the nitty-gritties of the details. And on the left side, it's a whole a stack of pipeline. For instance, let's just open the pose estimation, which is on the last Isaac ROS pose estimation. So here you can see, like that's how actually the pose estimation looks like. We've been talking about, pose for a long time. You have these bounding boxes. You go through the documentation. Can you scroll down a bit more
Sure.
towards the end? So here you see you have the quick starts, and on the top.
Yes.
Yes, so you have the quick starts. You can on different poses, or like on the different models that we have, for instance, center pose, dope, and foundation pose. Now, so the thing is, like, a lot of things are developing so fast. We try to capture all these things in a documentation, and also to deploy it, we also provide containers for it. So it just so the whole it really takes up a lot of building the wheel from the users, so that we just deliver it, and the users can just get their products really fast. So that's how we also provide multiple Docker containers through our NGC, and also some troubleshooting guidelines, some blogs, what are the FAQs, because a lot of there are some nitty-gritty things which happen. Maybe something that has been done by a developer couldn't be how you can use those packages. If you have a ROS2 code already, how you want to do it with Isaac ROS packages, what is NitROS, like all these basic things which are also documented. Also, another thing on talking about the on the robotics specifically, we also have Isaac Sim, which is now open sourced already. So for this, this was Isaac Sim is a package wherein you can simulate your robot with sensors. I think this is a very good images. You can see you have different sets of robots here, from the manipulator to a humanoid to a small wheeled robot. So all these assets actually come out of the box. So the users or the developers doesn't have to start from the scratch building their whole CAD environments. Just get those things out there, put in the sensors, put it in a scene, and then get the results outgoing. And since we have the Isaac Sim open source, we are more than happy for the developers to give a feedback, improve the improve our code, improve give a pull request, and that's how we learn together. Also on the on top of it, on Isaac Sim, we have Isaac Lab as well, and that's a learning a robot learning framework. So going from reinforcement learning, imitation learning, we also have teleoperation that can be integrated into it. So I mean, there's a lot of things I can keep on talking about the products and services offered by NVIDIA. And then right now I'm not even stepping on the Groot side, because Groot and Cosmos side, because that's a huge let's say story altogether. So really exciting times actually. Robotics and physical AI is really pushing the boundaries right now, and it's been the whole thing. I can say it's exciting time to be here in the robotics space right now.
I couldn't agree more. There's so much to learn, and things are changing so fast, but it's really interesting, and I just think how much of these tools is being available makes it accessible for people to learn. So through any of these courses, I'll share one more link to courses. This is our robotics fundamentals learning path. So this is, if you heard everything we just talked about and went, I don't know where to start, that's a lot. This really walks you through foundations of robotics, getting started with Isaac Sim, and then, as Kartik mentioned, Isaac Lab. And we have 2 new courses, Train Your First and Train Your Second Robot in Isaac Lab, that I'd like to highlight, and Isaac Ross courses. So this is the path. If you don't know where to start, you're overwhelmed, or you're really new to it, these would be the place to get started, and then we can go from there. And it's an exciting journey. So I'll share the link to that in the comments. And as we wrap up, guys, any final words? Thank you so much for joining today. Thanks for presenting. This is a really great dive into hard problems in industrial automation being approached with AI in really interesting ways. Thanks so much for joining. Any final words?
Thank you for having us. I mean, it's always fun to talk about the challenges that I face every day in my work, and also to share some of the results that we have. So this was great. Thank you.
Absolutely.
Yeah, on my side, a big shout out to the entire NVIDIA team. This great progress was supercharged with the awesome technology and the will to go to market from everybody from the NVIDIA team. So thank you very much, and thank you, Shane, for having us today and hosting this session. It was a pleasure, and would be happy to take another one when we have a real final deployment at a customer and show you how this is changing the life of people on the floor. Yeah,
we'd love to see it. Please come back. And everybody in the comments, please wish Edmar a good time off and to go enjoy his time off. But thanks everybody for joining. Have a great rest of your day. And quick reminder, actually, the Isaac Sim and Isaac Lab office hours are starting 12:30 p.m. Pacific. So that's in just under a half hour on Discord. So that's another great community resource. So thanks everybody for joining. Have a good day.
Thank you so much.
Bye, everyone.
Bye.
Thank you. Bye-bye.